Hi, I'm Brian Jepson, Senior Editor with O'Reilly Media, and I'm here with Federico Lucifredi, the author of the upcoming Sensor Interfaces for Arduino, Importing the Universe. What is this importing the universe? Sounds like something I might see in a program, like import universe.h or...
That's right. So the idea was that we usually import libraries and code, and that's what we're used to. But with Arduino, we're programming to the world at large. We're usually building automation as to what is happening out there.
So the book's talking about sensor interfaces, but you also talk about a lot of sensors. Mm-hmm. Now, to me, I think of a sensor maybe as a sound level sensor or light sensor, maybe even a volatile organic compound for gas sensors, right? And
sorry,
what other kind of sensors?
So there are a lot of types of sensors. Usually they tend to be all physical quantities.
Physical quantities.
Water level, distance of an object. Those are ranging sensors. Could be laser, it could be ultrasound, infrared. Typically for each type of quantity, there are a number of ways you could be measuring what's going on.
Geiger counter?
Geiger counter.
That's a sensor?
That's a sensor.
Okay.
Actually, it's a fun one to work with.
Yeah.
It's more than the radiation there. You're trying to generate randomness most of the time.
Right. So we should talk about that in a moment. But speaking of, how you use these things, I imagine it's relatively straightforward to connect a sensor to a microcontroller board or to your computer. You just hook a wire up, and maybe you have some resistors or even like a little chip in between them to act as an interface. But what about in your code? Let's say I want to, let's say I've figured out how to hook up a gas sensor.
Right.
And let's say, maybe I'm going to use that at a party to, as a breathalyzer, right? So people get
right.
drunk, and I hold the Arduino up to their mouth and say, you can either do this or you can take the field sobriety test, right? So what does that look like in my code? What am I?
It usually is fairly simple on the code side as well, because for most devices you can rely on libraries either made by the vendor or by some open source hardware vendor that the sensor was
So because some company that maybe doesn't even know that us open source hardware hackers exist, they make this cool sensor for breathalyzer manufacturers, right? Or for detecting dangerous situations. But when you get it home and you start playing with your Arduino and plugging it in, maybe you'll go and write a library for it because it helped you. And it's just as easy to share that, right? So
you can do that as well.
Yeah.
If you have very specific needs, you might wind up writing the library.
Yep.
For most sensors, I find that it's really very, very simple.
But some of them are they're just dead simple, right?
That's right. Because you're just reading either a pulse train or just a voltage, building a voltage bridge as you were describing before.
When you're reading a voltage, right? So it could be 0 to 5 volts, right? And the cool thing about certain microcontrollers, especially Arduino, is that they've got
they have a reference.
So they have a reference. They know what 5 volts is, and they know what 0 volts is. Is that what that means?
That's right.
And they also have this ADC, an analog digital converter.
Right.
And so
that makes it very easy. You're literally just writing a couple of function calls and then reasoning on the results of the output of these.
And the results are a value, right? 0. It's not 0 to 5.
It's just a number.
0 to, is it 1023 or 256? Or?
Well, it depends. Depends on what you're looking at. That's part of what I've been doing for the book.
Right.
I have an ADC box so that I can plug the sensor in there and characterize the entire range of the sensor.
Okay.
And I can say, well, the behavior of the sensor is that it goes linearly, or that it has a flat area and then it starts responding.
Yeah, so
you know what numbers to expect, and then it makes it easier to program against those functions.
So if you're programming against something that's just got a strict linear, like most potentiometers, right? Most knobs you turn, most of those are linear, right? And so 0 is 0 volts, and 1023 is 5 volts, or vice versa, depending on how you got it hooked up, right?
Right.
And then something in between, you just
scale it linear.
You just scale.
Others may have a dead zone where they don't trip for the first, 40 values, let's say, and then the linear behavior starts. So there is a little bit of adjustment here. But going back to your programming point, I find it extremely easy as someone that comes from programming to deal with sensors through Arduino, because once you have the information about the sensor, the programming model is very simple. You're setting up your system, and then you're just polling and firing events when something interesting happens. So I think the complexity is more around what you're trying to detect than the actual detection. So an example I usually like to make is that these sensors being so stuck on physical quantities make it hard to determine logical things, like is Brian home? So I could measure that someone with your weight was on a doormat at a certain point.
So let's stop there for a second. So a doormat, right? If I wanted to know that somebody with my weight was on the doormat, what sensor would I be using?
Just be using a straight contact. There are doormats that are made specifically with 2 blades of aluminum and a little bit of padding in between, so they flex when someone steps on them.
So, but
you can build them yourselves.
But how does it distinguish between somebody who weighs as much as me and someone who weighs half as much as me? Because there's got to be.
That's right. You're right. So this is just a direct track.
Okay,
there would be a weight sensor in there.
Right. So, is that the same thing as a force sensing resistor, or
that is?
Or is that does that mean you have to do more math? Are there sensors that will return a weight value?
There are. You could use a force sensing, but it's probably more expensive and more fragile that you would want in that case. Probably a piezo would be better for that sort of scenario.
And that's a piezo. A lot of people think of piezos as things that might make a buzz. They use them as buzzers.
That's also true.
But they're also sensors.
You can use them as sensors because when you put power into a piezo, it generates movement. But conversely, if you are putting force into it, it generates current.
So you can use it as a knock. You can use it as a knock sensor.
That too.
Right?
That too. And most scales sold in the United States at this point are basically simple piezo sensors.
Really? So an electronic scale has a piezo sensor in it, and so I did not know this. So just using a piezo, I can measure from 0 to whatever. I can say this is how much this object weighs, and it's based on the amount of energy.
It's not going to be as precise, but yeah.
And so it generates a certain amount of energy with a certain amount of weight or force, right? Okay. So that's
and it's more rugged than
a lot more rugged than a force sensing resistor,
right.
which.
So for something that's sitting on a mat outside, that would work well.
Right, with rain and all sorts of things like that. So, so you want to tell if somebody's at the door. Maybe you could have the door open for them. Geiger counters. We were just talking about that a little bit. Now, some people might want to use it to detect radiation. I mean, there's some things you might find that have radiation in them, like old watches or clocks with luminous dials.
Some types of printing ink for very good color have some degree of higher than background radioactivity. Bananas.
Yeah, bananas. That's
things
right.
With potassium.
Why do they? Okay, potassium. Why does potassium give off?
So there is a less common isotope of potassium that's a weak radio source. So
I don't have to worry about eating bananas.
No,
of course.
But for instance, the granite counter of your kitchen could also be a source, just because there is a little bit of uranium in it.
And you talked about
they're not dangerous, but they will create background.
But probably most people that hook a Geiger counter up to an Arduino are doing it for another reason, which you mentioned.
Right. Actually, we did cover that a couple of years ago at OSCOM in a talk. The idea is that you can use the pulses to generate randomness. So you can have a true source of randomness for your computer to
real
to refill
random
the
numbers,
entropy.
right? Can you spoof that? Like if I walked in with a chunk of uranium?
That's right. That like everything, there is a way to exploit it. So you could come in with a strong radio source, like maybe a broken smoke detector.
Okay.
And it would be bad for you because
bad for me.
you would probably get a skin burn, but you would max the source. So if you're using it as a source of random numbers, you probably want to shield it from obvious exploits, like putting it in a box. So
tamper evident, tamper resistant. Those are both important steps that you would take, right?
And the sensor that I'm using has an interesting interface, so it's easy to plug that into the Arduino as well, because you can detect the voltage spikes that come when a pulse is detected.
So, just curiously, how does a Geiger counter work? It's got a tube.
So the Geiger counter works that it's filled with it's a steel tube or metal tube with an inert gas inside. Usually there is a window at one end that's made of mica because it's neutral to the particles that we want to count. And the gas is inert, but it's kept between very high voltage plates. And in the specific case of the one I'm using, it's driven by a USB. So getting 500 volts out of USB is a pretty cool thing. It's very low current, but very high voltage.
Right.
And when an ionizing particle enters the tube, it strips one of the inert particles of electrons, and it creates a cascade so that there is a voltage spike. And all that the counter does is count these spikes or send them back to the piezo, in this case as an audio output, so that you hear this buzzing tick, tick, that we're used to in movies.
Yeah.
In more useful terms, we can use a USB interface to pull the data out, or interfacing with the Arduino. It's looking at the pulses on a certain pin.
So I'm sure you'll cover this in your book. But like right now, let's say I go find some random sensor that I'm interested in. Not random, obviously some sensor that I want, that I order online.
Mm-hmm.
And what's the best way to go about finding the right library for it? If I'm working with Arduino, usually my first instinct is to go to the Arduino Playground, which is a wiki on arduino.cc. Is that generally a good first stop?
It's definitely a very good first stop.
Well, actually, the first stop, I guess, should be to click on the file
documentation.
examples, or the Arduino's own built-in libraries, right? Sometimes you might find something, or is it more likely?
Sometimes, but it's usually either the Playground, where you can find older stuff and newer stuff mixed together, so you have to look at the dates.
It's hard to figure, yeah.
And the other one is looking at the vendor, like SparkFun and Adafruit are very good at providing documentation.
Both SparkFun and Adafruit carry sensors that you might be able to find at a electronics dealer, but both of them are going to include tutorials and comments and forums, so
code examples.
You're not just flying blind, right? Like if I go onto eBay and I order, a sensor directly from the vendor, the manufacturer actually. Mm-hmm. All I get is that thing in a static, a spec sheet.
So if you are a double E,
yes,
then you're comfortable with the spec sheet. I have a degree in computer science, so I don't know anything about that. And that's why I find SparkFun and Adafruit so helpful, because their value add is the documentation.
Right.
And I think they're setting the trend that other vendors are trying to include more documentation as well. So it's helping.
I think so. And the other thing, too, is you don't want to have to go and rewrite the code to support this. If somebody's already written it, and on the flip side is if you do end up writing some useful code, you want to share it, because that's a lot of what we're talking about here can be generalized to other microcontrollers, but we really are talking about Arduino is what your book is about, and I can Arduinos are really easy to get now. I can walk down to a Radio Shack and walk out with for less than $100 I can get an Arduino, I can get the USB cable, I need to connect a computer, and I can get one of those really cool parallax sensors, the distance sensors, like the ping sensor, and then you can create things that know how far people or cats, whatever, are away, right? So
right. In places like Radio Shack or Micro Center, they seem to
Micro
have
Center,
yes,
Micro Center is they have a really good collection. I think maybe even Fry's is carrying Arduinos. I'm an East Coast guy, so what do I know? You are too, right?
Yeah, and I'm not informed, but the availability is good, and it's easy to find documentation.
It's very easy to program.
Programming model is simple, so it's a fun way to spend time. I think the complexity is more looking at how to address the problem, what is the right approach, but once you start building it, it works fairly smoothly.
Well, thanks, Federico. I really look forward to your book coming out because it means I'm going to buy a bunch of sensors and try them all out.
I have an official excuse.
Official excuse to get all the stuff. Thanks so much. Really, really great talking with you.
Thanks, Brian.